to present you my project for batch 26 for data science retreat. The topic of my project is detecting humans in LiDAR images. The data was provided to me by Blickfeld. It's a company in Munich, that produces LiDAR sensors, just like Jose said earlier. So they are very compact sensors that are aimed at mass market. Okay, so I will talk even more about LiDAR, about what LiDAR is. So it's a technique, and the easiest way to describe it is to think of how bats work, how bats detect objects in their vicinity. So they are emitting sound waves, and the sound waves are reflected by objects, and well, this way the bats they can localize the objects in their vicinity and so on. So it's the same principle for LiDAR, only that the LiDAR does not use sound, but uses light, laser pulses. So a LiDAR sensor, it's composed by a transmitter and a receiver, as you can see on the left side of the slide. And what we get, so what's really important to know about LiDAR is that it gives us very precise information about the position in space of the objects that it detects. So here you can see the reconstruction of data that is recorded using LiDAR sensors. Some things that I would like to mention about this video that you are seeing. So first of all, you can see that everything gets points in this video, right? That's why this type of data is called point cloud. Then you can see that the angle from which you're looking at the image can change. So this is easily explained. So we have here coordinates. We have the coordinates of the points, and we can change the angle from which we look at it by simply applying a transformation to our. And also, so as you can see, it looks like it's a scene. It's a scene somewhere, maybe a train station or well, I don't know. We can easily notice people because, well, we are also humans. So for us, it's easy. We can notice people going through the scene. Okay. So what was my goal for this project was to take the data. So from this form that I showed you, which consists in a list of coordinates for all the points in the point cloud, and to transform this data into something that looks more computer vision friendly. So like the image on the right. And then as soon as I will have the data in this format, I would simply just apply a typical deep learning methods for image processing. So this was the goal. And the challenge was, of course, to get from point cloud, so from the image on the left, to where you notice that is a cat, right? To something like the image on the right, where it looks like a cat even more, like an image. And so to deal with this challenge, I had a few approaches, I had a few ideas, and the first one that I tried was to try to create a cube that will encompass my scene. It's an empty cube. It's filled with zeros, and then I would fill this cube with ones only, and only at the places or the coordinates where my point cloud tells me that I have detected points. So practically, I'm reconstructing the scene within this cube. And then my idea was to just take slices out of this cube and flatten it into images, and then try to process those images. But I immediately saw that this approach, well, I'm limited in this approach by the amount of memory that I need, because I got really huge images. And also, so on one hand, I got huge images, but then I also lost a lot of information because some of the coordinates were simply overlapping. And I lost the depth information. And so clearly it was not a good approach. But then I said, okay, maybe I can improve this approach. What if I give up the idea of a cube and I'm still choosing slices in space, and either on the X or on the Y direction, and I plot the same with the same idea. I'm flattening and plotting with the hope that I'm getting some good images. And the result looked like this. So here, if you look on the left side, you could say that you could see the shapes of some humans, right, in the 3D. But then when you look on the right side, you barely have some lines, so you don't keep the shape, you can no longer distinguish. So me as a person, I can no longer say if those are people or not. And when I looked at the complete scene, even more, I see that the slicing, it's kind of ruining my scene and does not help me. And the reasons were pretty much the same. I'm losing the depth information, and I'm losing the information at the points where the coordinates overlap. So I give up this idea as well. Then I said, okay, I will just take an off-the-shelf algorithm and try to cluster the points and see what I get. So as you can see on the left side, we have points that we can clearly say that they belong to different clusters, and by just applying a clustering algorithms, we can see that we can have a good result of for the clustering. And the idea was to use this technique to learn how a human looks in the point cloud, and then to apply this whatever model that I would learn to the complete scene and try to detect humans. Just applying the algorithm and plotting the result, you can see that I still get some shapes which look quite similar to what we saw earlier in the 3D scene. So it looks good, but well, it doesn't fit with the idea that I had in the beginning, that I want to go from the point cloud to images. So here I'm really just working on the coordinates on the point cloud itself. So I didn't continue with this idea, but I got some info, some insight that for my problem, the depth is important. So then how about if I just convert my data in a depth map? So what is a depth map? I'm showing you here an example. On the left side, we have a scene, a 3D scene with an elephant. And what we want to do is to get from this scene to the image on the right, where the points that are closer are brighter and the points that are farther away are darker. So it will be the same for my scene, for the people in my scene. The people that are closer would be brighter, the people that are farther away would be darker, but I would still keep the shape of the people. And I will have to choose either X or Y for my depth. So one of these coordinates will have to be transformed into depth. Well, at this moment, this is still work in progress. So I will not show you any outcome of this today. But what I can show you is what I would like to achieve when the depth map will be ready. So here we have another video that also you can find it on the website of Blickfeld. So it's a representation, it's a point cloud representation, and you can see the humans that are detected. So you can see the cuboid around the person, the same around the car. So this is pretty much the goal of the project, but not using point cloud, but using, sorry, I'm saying not too much, using images. Okay, what about the application of this? So you can see on the right side, you can see the sensor from Blickfeld, right, attached to a drone. And so we can already think about applications in the farming, in security, in smart cities application, but also on the left side, we can think about application in automotive. And actually, this is a very important, a very important field where we could apply this. Why? I mean, you could ask, okay, why? What's the difference between this sensor and a normal camera? Well, as we said, we keep the depth information. So at any moment, we know where the objects around us are. And also, this type of sensors, they are not affected by neither by the light conditions or the weather. So the weather could be bad, you could still use the sensor and see around you. I will just zoom on this image to where you have a vehicle and you have all the type of sensor that you can attach to this, not all of them, but some of the type of sensors you can attach. And you can see how Lidar, so everything that's in yellow, covers quite a lot compared to all the others. And so it's really complementary to everything else. So with this image, I thank you to you.